Hey everybody, welcome to another episode of Blockchain Central. Today I'll try to break down how the proof of work technology works. Before we start, please know that the content does neither represent financial, legal, or tax advice, nor is it supposed to be understood or interpreted as solicitation to buy or sell any securities, coins, or tokens. We're going to unravel the science behind the proof of work consensus mechanism underlying Bitcoin and other unpermissioned blockchains. The word unpermissioned means that everybody has access to the system and everybody is allowed to write onto the blockchain. This stands in contrast to the enterprise blockchains being built right now, where only some predetermined nodes are allowed to write onto them. In the blockchain system, everybody is allowed to validate transactions and add blocks to the blockchain. When it comes to the consensus mechanism, it is a way to counteract the inherent disorder of an unpermissioned system. When everybody records information, a mutually agreed set of data is needed. One of those mechanisms is a proof of work mechanism. So far, the most popular and by far the most secure one. Broken down, proof of work means that a certain amount of work, in the case of Bitcoin, the work is the computing power, has to be poured into the system. So let's assume a person, Alice, wants to send a Bitcoin to Bob. She's broadcasting the transaction to the network. Her transaction, along with other transactions, is being collected in the Bitcoin meme pool. The meme pool is nothing more than a virtual pool where the transactions are being collected before they're validated. The miners who have access to the meme pool pick some of those transactions, preferably the more profitable ones that come with a higher transaction fee. Then the working part begins. To understand how this works, we first need to understand what a block and a blockchain consist of. The main parts of a block are the digital fingerprint of the last block generating an unaltered connection between two successful blocks, a timestamp when the block was created, a digital fingerprint of the accumulated transactions in a block, the so-called Merkle root, and a so-called nonce, which is just a number. Then, the required work consists of finding a digital fingerprint, a so-called hash, that fulfills certain criteria. What is a hash? In a nutshell, it is a digital fingerprint. Every digital value can be fingerprinted, or rather hashed. For example, using the most common hashing algorithm, the SHA-256, the hash of the word hello with a lowercase h is. However, if you change the lowercase h to an uppercase H, as in hello, the hash becomes. So we can clearly see that if the input data is slightly changed, the output data changes completely. Currently, each Bitcoin hash has to have 18 leading zeros. The amount of zeros determines the difficulty in Bitcoin. The more leading zeros are required, the more difficult it is to find the hash. Among other things, each block includes a digital fingerprint, or the hash of the last block, the hash of the transaction data, and a timestamp. These are the data which cannot be changed in any way, as it would compromise the system. Therefore, the only adjustable parameter is the nonce. The miners choose a nonce randomly. Then they hash the data and compare the output with the specified hash target. If the target is not met, a new nonce has to be tried out. The whole process is based on so-called brute force, which means that no shortcuts are allowed, and that's exactly what requires a lot of computational resources and therefore energy. As soon as a correct nonce, which is generating a target hash, is found, the block is broadcasted to the network and the miner receives the block reward, which is currently set at 12.5 Bitcoins, plus the transaction fees for this given block. The block is then added to the blockchain, meaning that the whole transaction history is updated by every node in the network. The miners then start to work on the next block, competing again to find the correct nonce for the next block. So, what do we take away from this video? Proof of work, POV, is the consensus mechanism used by blockchain system and other blockchains. A consensus mechanism is needed in unpermissioned blockchains to make sure that all nodes in the network write the same data so that a common truth is created. The POV mechanism is by far the most secure mechanism in unpermissioned blockchains by now, and therefore also used in other blockchains. The proof consists of finding a number, which together with the data in the block generates a digital fingerprint that is required to fulfill certain criteria. The whole process is very energy intensive as there is no shortcut to finding the solution, and the only way to finding it is by investing huge amounts of computational resources. Having found the nonce, which satisfies the requirements, the miner gets rewarded with Bitcoins. Due to high energy requirements, other mechanisms are currently being developed and tested. That is it for this episode of Blockchain Central. Make sure to hit the like button if you like this video, and don't forget to subscribe to Blockchain Central to never miss a beat. Happy investing.